Hello and good morning. I'm confident you will be all right. You worked hard, just a few organic reminders, yeah? In the context of organic, there's a couple of things I'd remind you. First of all, homologous. Homologous means family, right? Means family of things. For example, there's a couple of homologous series. For example, there's alkanes, right? There's alkenes. This is a unique homologous. Alkanes is a unique homologous. Alkenes are unique homologous. Alcohols, it's a unique family. Alcohol, so that's a homologous. Carboxylic acids, etc., etc. So each of these are a homologous series or family. So to belong to a certain family or to belong to a homologous, what are some characteristics? One, they will have the same functional group. They'll have the same what? Functional group. Two, because they have the same functional group, for example, all alkenes have single to single carbon bonds, that's their functional group. All alkanes have double carbon to carbon bonds, that's their functional groups. All alcohols will have the OH. And then all carboxylic acids will have the double C, will have the C double bond O and the OH. See, these are what we call functional groups, because if you belong to a homologous series, you'll have the same functional groups. Because you have the same functional groups, this will mean that you all have similar chemical properties. Similar chemical properties, yeah. Similar chemical properties. In addition to having similar chemical properties, if you belong to the same homologous, you might have, for example, you'll share the same general formula. You'll have the same general formula, yeah. For example, the general formula of alkanes is CnH2n plus 2. The general formula of alkenes is CnH2n. The general formula of alcohols is CnH2n plus 1 OH. And then the general formula of carboxylic acids is CnH2n. Let me write it here. Carboxylic acids, it's CnH2n plus 1 COOH. I hope that makes sense, yeah? So these are the general formulas. So everyone in that family will have the same general formula. Then fourth, their physical properties won't be the same, obviously, but their physical properties will change. But their physical properties will change in a predictable trend. In a predictable trend. Okay, trend. Can't fit there. So physical properties will change in a predictable trend. I hope that makes sense, yeah? So homologous series, everyone has the same functional group. Single bond, double bond, OH, whatever the family they belong to. Because they're the same functional group, everyone has similar chemical properties, right? It means they all kind of react in the same way. They'll share the same general formula for alkanes, alkenes, alcohols, carboxylic acids, 2N plus 1, COH for carboxylic acid. And of course, their physical properties, while not the same, but their physical properties will change in a predictable trend. I hope that makes perfect sense to you, yeah? Perfect sense. All right. So far, so good. Most organic, let's talk about combustion reactions first of all. Combustion, right? Most hydrocarbons, what's a hydrocarbon, by the way? A hydrocarbon is something that contains, contains only the elements or only atoms of carbon and hydrogen. Only atoms of carbon and hydrogen. That's a hydrocarbon. So most hydrocarbons, when you burn them, I'll take this for example, C2H4. Most hydrocarbons, when you burn them, when you combust them, so combustion is burning in oxygen. What is combustion? Burning in oxygen. Will produce either CO2 if it's complete combustion. Complete combustion will produce CO2 and water. Okay, and your job is just to balance it. If it's incomplete combustion, it will produce CO and water, carbon monoxide and water. So complete combustion, CO2, and incomplete combustion will produce CO and water. All right, your job is just to balance them. For example, if I was balancing the top equation, I see there are 2 carbons there, I'll put a 2 there, and then I see that there are 4 hydrogens, I'll put a 2 there again, and I think that, then so there's 6 hydrogens, 6 oxygens, so I'll put a 3 there. I hope that makes perfect sense, yeah? Right, that's just a brief aside. Now, main business. Let's focus first of all on alkanes. Functional group, single carbon to carbon bonds. Are they saturated or unsaturated? We say alkanes are saturated. Why are they saturated? They contain only single carbon to carbon bonds to which we cannot add. All right? So since we cannot add to alkanes, we need to substitute, which is what our subject now is. So they're saturated because they contain only single to single carbon bonds to which we cannot add. This is your alkanes. All right, so let's begin. So the first alkane, since they all have single bonds, is called me. Me is one, isn't it? Me is one. So this is methane. Me tells me you have 1 carbon, and ane tells me you belong to the family of alkanes. The next one is eth. Ethane. Eth tells me I have 2 carbons. Eth is 2 carbons. Ane, family of alkanes. Again. 3 is pro. Pro what? Propane. If you said that, you guessed it correctly. Propane. Pro tells me that there are how many carbons? There are 3 carbons. Prop is 3 carbons. Ane, family of alkanes. I think you get the gist, isn't it? Bute. How many carbons? 4, obviously. Bute, 4 carbons. 4 carbons. So butane. Bute for 4 carbons. Ane, family of alkanes. All single bonds. All what? Single bonds. If I'm an alkane, we're all single bonds. I think we get the gist of this, right? So me, 1. Eth, 2. Prop, 3. Bute, 4. Pent, 5. Hex, 6. Hept, 7. Oct, 8. Non, 9. Dec, 10. All right. So I think as long as you remember the first 5, you generally should be okay. All right. Let's move on. So, reactions of alkanes. Still discussing alkanes. This is our first family for discussion. Alkanes family. Alkanes all have single bonds, and therefore, what kind of reactions do they? They say that Cl2. The chlorine can only sub a hydrogen. 1 chlorine subs 1 hydrogen. Do not sub more than 1 unless the examiner gives you context. 1 chlorine subs 1 hydrogen. You know, like how you sub. You know how like you sub a soccer player of the team or rugby player of the team? 1 chlorine subs 1 hydrogen. So I'm going to put a chlorine in its place. And therefore, since I've removed a hydrogen, it bonds with the other chlorine that's left behind, forming hydrogen chloride. Forming what? Hydrogen chloride. You'll note that this is not hydrochloric acid. Chloride. Hydrogen chloride. It is not hydrochloric acid because there's no water. So it's HCl, but it is not hydrochloric acid. It's a covalent bond. So the hydrogen chloride is what it is. Most kids kind of make the mistake and call it HCl, hydrochloric acid. It is not hydrochloric acid. It is hydrogen chloride. Right. And of course, what's happened here? You've got a chlorine here. You see this? Here there's a chlorine at the end. So you only sub one chlorine for one hydrogen unless you have context that suggests otherwise. Okay. It is possible to sub all the hydrogens, for example, but there must be context. Otherwise, if you're doing this, the examiner suggests that you do this, you always sub one chlorine for one hydrogen. Now, what kind of reaction is this? Because you've subbed, it could be called substitution. Substitution. But what are the conditions for this reaction? What did you think? What are the conditions? This condition requires UV light. It requires what? UV light. And therefore, it could also be called a photochemical reaction. What could it be called? A photochemical reaction. What could it be called? A photochemical reaction, because it requires UV light. So remember, what conditions do alkanes need to react? They require, make note, UV light. And therefore can be called a photochemical, because the Greek word for light is photo. But another way of calling it is called a substitution reaction, because you're subbing one chlorine for one hydrogen. All right, I hope you're clear on alkanes. Next family is alkenes. What is their functional group? Their functional group is the carbon double carbon to carbon bond. Always write it like that. It's called a double carbon to carbon bond. This is their functional group. Are they saturated or unsaturated? These ones are unsaturated. And unsaturated. My dyslexia. They're unsaturated. Why? Because they have double bonds. Double carbon to carbon bonds. See, I'm being lazy. Double carbon to carbon bonds. Double carbon to carbon bonds, to which we can add. Hence unsaturated. Whereas alkanes were said to be saturated because they have single carbon to carbon bonds. Saturated, single, unsaturated, double. Because we can add to the double bonds and it's not full in a sense. All right, we can take more. All right, so the first alkene you'll note is there's no methane. Right, that methane does not exist because methane would imply there's one carbon, but the smallest you need for an alkane is a double carbon to carbon bond. The smallest you need is a double carbon to carbon bond, isn't it? So it's ethene is the simplest one. Ethene is the simplest one. Ethene is the simplest one. Right, so ethene is the simplest one. How do they react? Say, for example, I reacted with Br2, right? What happens to the double bond? What happens? The Br2 attacks, you might say, the double bond, acts on the double bond. What happens to the double bond? The double bond opens up. It opens up. So one end, it will receive a Br on the one carbon, and the other carbon, it receives a Br. Do you see that? And then, of course, this is now gone. So what color was Br2? We call this aqueous bromine. Aqueous bromine was yellow. What color was it? It was yellow. Aqueous bromine was yellow. And of course, when the reaction has happened, it changed from yellow, it discolorizes, or it becomes colorless. So what is the test for the double bond? What is the test for the double bond? We add aqueous bromine. And what happens to the aqueous bromine? It turns colorless. I hope that makes sense. Aqueous bromine, which was yellow, turns colorless when it has been absorbed by the double bond. I hope that makes sense, right? Now, here's another example. Have a look. You've got that. Always make sure that each carbon has how many bonds? Each carbon should have 4 bonds. Double check. Always count that. This has 1, 2, 3, 4, 1, 2, 3, 4. So each carbon has double bonds, right? Now, I reacted with bromine again. What color is this guy? He's orange initially. Aqueous bromine is orange. Bromine gas is brown. So most kids are tempted to call this brown. It ain't brown. It's orange, right? Now, the double bromine comes to where the double bonds were. All right. So where the double bonds were, you must put one Br and the other Br. I hope that makes sense. Where the double bonds were. Some kids will make this. So this is the correct answer. All right, this is the correct answer. I'm going to just draw the wrong answer. That's what you see what some kids do. Some kids would have the Br here and have the H here. Do you see what's wrong with this? This is wrong because the double bond was here. The double bond was here. And the BR needs to go, both the BRs need to go where the double bond was. All right, I hope that makes sense. That both the BRs have to go where the double bond was. So here you will put BR, and that is the H. All right, I hope that makes perfect sense. Give me 2 seconds. Right, nearly there. The end is 9. So that's how they react, right? So how do you test for the double bond? You add Bl2. The next thing you need to learn, still on alkenes, is this. This time I want to react it with water, more in particular steam. So what is water? That's a deep question. What is water? Water is, as you know, is OH, right? So what you can do is, remember, you can break the water here into OH and H. So on this end, what would come here on this end? On this end would come the O and then the H. And on this end, you'd get the H. Does that make sense? So you'd get this in the end. Does that make sense? So the double bond is gone. Where the double bond was, you've got O, H, and H. Does it make sense? OH and H. And what you've now formed from ethene, you've got ethanol as a result. You've got ethanol. So it's easy. How do you make your own alcohol? All you have to do is get a little bit of water and an alkene, and you can run your own beer hall from the backyard. Do resist the temptation to try that. Do not. All right. So basically, you take ethene, add water, and you're going to get ethanol. I hope that makes perfect sense, right? Take ethene, add water, and you get ethanol. Easy. Perfect sense, right? So, what are the conditions for this reactions? Now it gets hard for some conditions. Well, you need 300 degrees Celsius. Remember that. That's the temperature. Your pressure is 60 atmospheres. And your catalyst is phosphoric acid. Phosphoric acid. That's your catalyst. Phosphoric acid. How you can read that. Phosphoric acid. That's the catalyst. Okay. So I hope you're clear on that. So how do you make alcohol? All you need is water. How do you make alcohol? All you need is water. Now that we've made some alcohol, right? Like, for example, we've made ethanol from the previous question, haven't we? We've made what? Ethanol. From the ethanol, in fact, this is probably called ethan 1 or, because it's on carbon number 1, isn't it? The OH is on the first carbon there. And remember, you can count either coming this way, either coming this way, or count going the other way, right? Depending on which one gives you the smaller number. So this is ethan 1-ol, right? And usually to make esters, we're going to be using 1-ol, propan 1-ol, butan 1-ol to make esters, right? So just bear that in mind, right? In the ester making. Anyway, so we've got an alcohol now, And then if you then oxidize this, oh, now it gets even more interesting. You oxidize this. In oxidation, what are you doing? You're removing. What are you doing in oxygen? You remove these hydrogens here, and the oxygen in a sense comes here, and you form a double bond O there. And what have you formed instead now? You formed an acid, carboxylic acid. So from ethanol, by oxidation, you then form a carboxylic acid. You form ethanoic acid. You form what? Ethanoic acid. What do you form? Ethanoic acid. I hope that makes sense. So what's the oxidizing agent? What we use to oxidize. And the agent is acidified. Please note, acidified. It must be acidified. Potassium manganate 7 with Roman numerals. Do you get that? Potassium manganate 7 in Roman numerals. Okay, that is the acidifying, that is the oxidizing agent. This is the oxidizing agent. All right, do you think you can remember this? I'm going to summarize it for you now very quickly. But the oxidizing agent is acidified potassium manganate 7. All right, so what have we learned? We've learned that you can take an alkene and turn it into an alcohol, into all, using what? Water. All you need is water, that. You know, all you need is water, and you can run your own beer hall. Do not try this at home. It's very dangerous. So H2O, right? E3 300 degrees Celsius, 60 atmospheres for pressure, and phosphoric acid for a catalyst. Okay, so into all, and then all, take an alcohol and make an acid. So into all to acid. An alkene becomes an alcohol by adding water, and then an alcohol can then become an acid by oxidation. By what? Oxidation using what? Potassium manganate 7. Okay. I hope that makes sense. Acidified. Must be acidified, right? Acidified potassium manganate 7. I hope that makes perfect sense to you. An alcohol becoming an acid by oxidation. And then, of course, now, here's the interesting bit. My favorite part of the story is that the alcohol and the acid have a secret love affair under the bridge. Secret love affair. It reminds me of Romeo and Juliet. And together they make baby Esther from their secret love affair. Stork brings them baby Esther. All right. So, what do I mean? So take an alcohol like this one. Can you see the alcohol? And then this is an acid, isn't it? Name of alcohol. This is ethanol. Ethan 1O, correct? Ethan 1O. It's on carbon number 1 because for ester purposes it needs to be 1O, isn't it? For ester purposes it needs to be 1O. And just 2 carbons, so it's ethanol, ethan 1O. And then of course this has 1 carbon, so it's methanoic acid. Methanoic acid. Now pay attention. If you're sleeping, wake up now. This is important. For the acid, where do you always rub it out? From the acid, please note, you rub out the OH. From the acid, you rub out the OH. From the alcohol, you rub the H. From the alcohol, you rub the H. And then you join them together. You do what? You join them together. So always remember this O, I like to associate with the alcohol. If you see an O, maybe they give you a complete picture. And then the other bit would have been the acid, all right? Would have been the acid, in case you have to redraw it again. How do I name it? I always begin with the alcohol first, so it's ethyl for the alcohol. And then the acid methanoate. Okay, do you see how to name it? But what you rub for the acid, erase OH. For the alcohol, erase just the H. Okay? All right, I hope that makes sense. And of course, you will recognize Cu. Do you see Cu? Cu, C-O-O. This is what we call the ester linkage. Ester linkage. Anyway, I hope that helps. Take care and best wishes. I'll try and send isomerism just now.